Hello everyone. Today's question is implement try prefix tree. Implemented a try with insert search and start with method. So note you may assume that all inputs are consist of lowercase letter A to Z. All inputs are guaranteed to be non-empty string. First we will understand the implementation in pen and paper and then we will move to the coding part. Using try data structure we can able to perform insert, search, remove and start with prefix. In our questions we can only perform insert, search and start with. So now we can perform all three operations in this try using order of in time complexity. Here n is represent length of the string. Let me ask you something interesting, that we already have another data structure, that is hash map, which provide us order of n. N is represent here the length of the string. So why we need this tries data structure? With the help of tries we can insert and search a string in order of n time, where n represent length of a single word. This is obvious faster than BST and faster than hash map also. So this is also faster hash map because of it way it's implemented. So we do not need to compute any hash function and no collision handling is required, like do open addressing and separate chaining. And another advantage is tries is can easily using tries we can easily print all word in alphabetical order, which is not easily possible with hashing. So we can efficiently do prefix search, so with the help of tries. So this is also not possible with hashing and BST. So this is the advantage of tries, and there is some disadvantage also. The main disadvantage of tries is that they need a lot of memory to storing a string. In description I will provide you a link. You can learn a lot about tries data structure. So using this try as an example we will understand three operations, that is insert, search and start with. So first I will take a string that is apple and we will try to insert it in this tries. So first letter of this string is A. So we check A is present in root dot next. Yes, A is present. So if the letter is present in this tries, so we don't need to add again in this tries. So next is P. So we check A dot next is P. There is any string that is start with AP? No. So we add P next to A and then again check P and add next to P, and again L, we add L next to P and E next to L. And now we check if we search some element like apple. So at the end of this apple we check there is termination or not. Means after apple there is another letter present or not. If there is another letter present then our result should be false. Because as you can see in add, at the end of this add we add a termination. Add a termination means we add forward slash as our termination. So if we got termination after end of this word means this word is present in our tries. So if you perform a search operation in tries, at the end you check there is a termination character present or not. If termination character matched after end of your desired searching word, then the result should be true. So in another case, in third method in that is required in our questions, that is start with prefix. So if you want to search app in this tries, the result should be true, because this is a part. If you want to search part of the string, then you have to use start with prefix. So start with prefix, don't check there is termination or not. There is a difference between search and start with. Search check at the end of this string there is a termination, then this is return true as a answer. In start with prefix, this is just check three letter here. app is present in this trace, yes present, then simple return true. If it is not present, app is not present in this tries, then we will return false. So that's all about tries. So let's move to the implementation of tries. First I will make a class of tree node, tries node, and inside this tries node we declare a constructor, and inside this constructor and we add a dictionary. We take a dictionary, self dot next equals to dictionary. So now inside this tries class, so in this constructor we call self dot root equals to try node. So in insert, first we cur is point to self dot root, and now we iteratively check all letter in word. If I not in cur dot next means root dot next, then we add cur dot next I equals to tries node. We push it into this tries node, and if it is present, and then or after adding it we just move the pointer, and then at the end of this string we add a termination, that is here we use forward slash. So in search operation we same we take a curve that is point to root, and we check iteratively each letter in word that is matched and that is present in our tries or not. We check the I is not in tries, then if it is not in tries, then we simply return false, and we move the pointer car equals to car dot next, and at the end of this loop we check our string is end with any termination character or not. So here we use termination character, that is forward slash. We check forward slash in car dot next. If forward slash is not in car dot next, then if it is present, then we will return true. If forward slash not in car dot next, then we will return false, otherwise we return true. So now last is start with. So again we use a car that is pointing to self dot root, and check the prefix iteratively I in prefix, and check if I in car dot next, not in car dot next. If I not in car dot next, then we will return false. Car equals to car dot next, we move the pointer, and at the end we return true, means if all the character matched with tries, then we return. Here we not check any termination. So now we submit it. Yes, got accepted. Thank you for watching this video. If you are new to this channel, please consider subscribe and don't forget to hit the bell icon.